In this video, I'd like to talk about the period of sinusoidal functions from their equations. And here we have the graph of the equation y is equal to the sine of the angle x. Though for sinusoidal functions, this could also be the cosine, since sine and cosine are really just shifted versions of each other. And what we've seen in previous videos is that for this sinusoidal function, the equation of a sinusoidal function, if we multiply the sinusoidal function in front by some constant a, then this will affect the amplitude, essentially how far the peaks and the valleys are from the midline. And we've also seen that if we add some constant, let's say some constant b to the outside, that this will shift this midline, which by the way has the equation y equals 0 for the parent function. This constant b will shift this midline either up or down depending if b is positive or negative. If it's, for instance, plus 3, it will shift all the y values up 3 units, and the new midline would be y is equal to 3. And for the period, this is a little bit more complicated since we will essentially need to multiply this independent variable x by another constant. And we will have to deal with horizontal stretching or scaling. But before we discuss that, let's think about what the period is of our parent function. And just remind ourselves what period actually means anyways. Now, the period can be defined in a couple different ways, but it's basically one section of this sinusoidal function that is unique, that will then repeat infinitely many times. So if we look at this section here, starting at the origin, we go up, then it comes back down through the midline, it goes down to its minimum, and then comes back up, essentially back to its starting value, and then it will repeat the process again. So this distance here from 0 to 2 pi, this is what we would call one period. In fact, we can say that the period of this sinusoidal function, this parent function, the sine of x, this is just 2 pi. And essentially, every 2 pi, this period will repeat. And we can see if we started over here at minus 2 pi, we go up to the maximum, down through the midline to the minimum, and then back up to the starting value, and then that will repeat. And again, it will repeat infinitely many times. Now, I mentioned we could also define the period in another way. We can look at it as the distance between consecutive maximum points, and this difference here would also be 2 pi if you calculate that. Or it could be the distance between consecutive minimum points, which again would be 2 pi. Though you can pick any point on the function, and as long as you go through one full rotation, so ending back here, then that would be the period as well if you calculate the horizontal distance between the 2 points. So we can choose any starting point just as long as we go through one unique repetition, and then that section will repeat infinitely many times. Now, like I mentioned, the main way to affect the period is to multiply the independent variable by some constant. We essentially need to horizontally stretch or squish this function. So let me just make a little bit more room here. And let's first consider just what happens when we multiply this parent function on the inside by some constant. Let's say we have y is equal to the sine of c times by x. And by multiplying on the inside, we will deal with what we call horizontal stretching or squishing, depending on which direction the stretching will happen. And if we first consider the case, let's say when c is equal to 2, so we have y is equal to the sine of twice x, we can consider plotting this by making a table or using the unit circle. So if I draw in a unit circle here, remember that any point xy on this circle with radius 1 centered at the origin has an x value equal to the cosine of the angle, and in this case we can call the angle theta, some Greek letter. and the y value is the sine of that angle theta. And when we go through this function here, though on the unit circle this would be theta, since that would be our independent variable, that's our angle here, we will essentially go through the values of the sine function, the y values, twice as fast. When we plug in 0, the y value is still 0 there, just like our parent function. Let me graph this in a green color. So it will still go through that origin, but now when we plug in pi over 4, that will give us pi over 2 on the inside, and at pi over 2 radians, the y value there is 1. So at pi over 4, we are now at 1. And at pi over 2, when we plug that in, we get the sine of pi. So the 2's will cancel out, and at pi, the y value or the sine value is 0. And when we go through at 3 pi over 4, we will end up at -1, since 3 pi over 4 will be the same as 3 pi over 2, which is down here, a 270-degree angle, or 3 pi over 2 radian angle. And when we plug in pi, this will just be the sine of 2 pi, which we know is back here, and the y value there is 0. And what we can see is that essentially it cycles through the values twice as fast. Or in other words, it squished the function. It squished it in half. So the period for this, let me use a brighter color, the period for this would be half the period of the parent function. The period of the parent function went from 0 to 2 pi. That was one unique oscillation here. But the period for our new function, y is equal to sine of 2x, goes through one unique repetition in pi units, which is half of the period from the parent function. So our period here is simply pi. Or in other words, when c is greater than 1, this is what we'll see if we try this pattern out with other values of c greater than 1. When c is a positive number and greater than 1, we will end up with a horizontal squish. Essentially, the function will contract closer to this y-axis here. And this is not the greatest picture, so let me paste in a picture that looks a little bit clearer. But again, we can see that this is the sine of 2x, where our period is half of what it used to be compared to that parent function. So now we'll go through 2 periods before we get to 2 pi rather than 1 period like we saw with the parent function for the sine of x.